All right, guys, we're going to get going with lesson chapter 10, section 7. This is areas of circles and sectors. The area calculation of a circle, I think everybody knows. Area equals pi r squared. But we're going to have to use that to find sectors and segments and some new things that you may not be familiar with. It's not that hard. It's all taking sections of a circle in some ways. So let's start with a sector. A sector is basically, if you take a circle, a sector is a portion of that circle. It's the area of a portion of a circle. The way you would compare it to is like a pie piece. Now, keep in mind that a sector has to go all the way to the center. So in the case of the book, I think they've got R, S, and P, and they're going to use arc RS as a way to help find the area of the sector itself too. All right, so here's how you do it. Basically, if you look at theorem 10-12, it's saying that the measure of the arc, RS, divided by 360. Why divided by 360? Well, it's because that arc is a section of a 360-degree circle, and what it does is it gives us a ratio. Then we can multiply the entire area of the circle by. So let's say that this measure of RS was 80 degrees right here. Well, that would mean that we'd have 80 over 360 times, use that as times, the area of the entire circle. And that's going to be the area of our sector. So the area of a sector is equal to the ratio of the arc that forms the sector divided by 360 total degrees in the circle times the overall area of the circle. All right, let me erase that and we'll do a problem. Hopefully it will make a little bit more sense. Again, you just need the ratio of the arc that forms the sector over 360. And then you're basically going to cut the pi piece by that ratio. That's what sectors are. All right, so here's how we would do it. In this problem, we've got a circle. This circle is circle P. So there's our center. It's really not very much in the center, but it'll work. So circle P with the center right there. It goes to G and H here. So G is here, H is here. And we've got a 15 centimeter radius. So that's 15 centimeters between P and H, which is also known as the radius. Okay? And we've got a 72-degree arc right there. All right, so what we're going to do to take the area of the sector is take 72 degrees over 360. I'll erase that because it looked like a 9 when I actually did it. 72 degrees divided by 360 times the overall area of the circle, which is pi r squared, which is pi times 15 squared, or 225 pi. Well, if we take our calculator and do 72 divided by 360, you get 0.2, or it could be simplified to 1/5 as a fraction. 0.2 times 225 is 45 pi. Whoops, again, it's been a couple of days since I've used this to write. So 45 pi is the overall area of the sector, which is this shaded portion in the middle here. The area of the overall circle would have been 225 pi. Look at your Math Excel assignments and be sure and be careful as to whether or not it says to leave it in terms of pi or not. All right. Erase this. And we've got one other little section of circles that we've got to deal with. That's a sector. The last thing is a segment. Okay, so here you've got a circle. That's the area of our overall circle. This is a sector. Okay, but you also have what's called a segment. So I'm going to draw another circle. This is a sector right here. In fact, I'll even label them so you can see it. And this is what's going to be called a segment. It's the segment of a circle. It's basically a segment that goes across a circle. And the segment is the area of that section created by that little chord across the circle. Well, here's the interesting thing about segments. If you take the sector that forms the segment, do you see how the overall sector minus that triangle gives us the segment? So when we're doing area calculations of a segment, I'm going to do area of a segment, this is your formula, is equal to the area of the sector, SEC, that's the sector, minus the area of the triangle, that's the extra portion, which I'm poking right there, that triangle right there. All right, so let me show you an example of how these problems work. It's going to require a little bit of extra knowledge because you're going to have to use areas of triangles, 1/2 base times height, or 1/2 BC sine of A, depending upon the information that you've been given. Could require a little bit of trig because of that. And you're going to have to calculate the overall area of a sector and keep all this stuff straight. So it gets a little bit more confusing at this level. All right, so here we've got a circle. And inside of this circle is this triangle ABC. Let's put C as the center. There's A and there's B. But we want the area of this segment down here. Okay. The information we're given is a 60-degree angle and an 18-inch. So that right there is 60 degrees as the angle. And we've got an 18-inch radius. Okay. So first of all, we need to find the area of the circle. Remember that the formula is the area of the circle minus the area of the triangle, or times, the percentage of the arc that forms the sector, so we can get the area of the sector. So our circle itself is 18 squared, which is 324 pi. So the area of the circle equals 324 pi. Let me check our time real quick. Got just 8 minutes in, so we're doing good there. All right. Well, we have to multiply that by our arc from A to B. Well, remember that the central angle forms the arc, and so this arc also has to be 60 degrees. And so we would take 60 divided by 360, which obviously simplifies down to 1/6. Okay, so 1/6 times 324 pi is our sector. Well, 324 divided by 6 is 54 pi. So this is the area of our sector. But now we also have to find the area of that triangle. Okay? Well, we know that this triangle, if I were to pull it out like this and label it, we know it's isosceles because these pieces are both 18. They're formed by a radius. Okay? So to find the area of that, perhaps the easiest way is just 1/2 BC sine of A. Or you can do 1/2 base times height. Draw your height in there and make sure you get it correctly. I got to make sure I'm using the right uh, times here. It just depends on how you want to do it. I'm looking to see which way the book did. If I split that in half, then I would have a 30-degree angle there. And I could find the height that way. What is the easiest way? The area is 1/2 BC sine of A. Let's go ahead and finish doing the triangle correctly. Let's do the whole triangle. It'll take a little bit more time, but I want to be able to see it fully. And this is what I would suggest doing too. So here's my triangle. I know this is 18. I know this is 18. If I use one of those as the base and everything has to be 60, it's an equilateral triangle because I've got a 60-degree angle up here and both of these are the same, so it's an equilateral triangle. That's going to help. I also know this is 18 down here. Well, all I need is the height right there, which is going to be formed from a 30, 60, 90 triangle, which makes our calculations a little bit easier. Okay. So this 30 side is x, 2x for the hypotenuse, and x radical 3 over there. Well, the x has to be 9, right? And so my height has to be 9 radical 3 right in there. So my area of my triangle, well, that's supposed to be a triangle. I didn't end up doing a very good job. Let me just erase it. This will just be the area of a triangle, is equal to 1/2 my base. And my base in this case should be 18 times my height, which we just found as a 30, 60, 90 side. There's the 60 side, 9 radical 3. So half of 18 is 9. And 9 times 9 is 81 radical 3. The area of my triangle is 81 radical 3. So what is my overall area of my segment? Well, it's going to be the area of the sector, which was 1/6 of 324 pi, or 54 pi, minus the 81 radical 3 that we got for the area of the triangle. You could then use a calculator to estimate to the nearest 10th, 100th, however many decimal places they say. It's going to be approximately 29.35 is what it looks like, 29.35. And that should give you a good example. You can see that these particular problems are much more involved, so you need to be careful with them. Go slowly, and please write out, like I was doing up here, although I ran out of space, the area of the circle times the percentage of the sector, so you get the area of the sector, and then subtract from the area of the sector the area of the triangle which forms the segment, and then you have the overall area of the segment. Hope that helps, guys, but if not, please just contact me via email or text and let me know if you're having any difficulties. Have a good weekend.